Alright everybody, here's a second example I have. So we've got a plate that's hooked onto the wall and then being held by two cables. And what we're trying to find here is the resultant force acting at point A, which is, as you see, is along the z-axis. We're also saying that the position vector, or to show the position vector and its magnitude. So I've written out my approach. I'm finding points at A, B, and C. So I've actually has to find my points. And then I'm going to write out my position vector, compute the magnitude, and then develop my unit vector, multiply the force acting along the line of action times the unit vector, and then I'll use vector addition to find my resultant force. So the first thing I will do is you can find your points. So if you're looking at your points, point A would be 0, 0, and 4 meters. Point B would be, so we're going 4 meters in the X, nothing in the Y, and nothing in the Z. And then point C, you're going to have 4 meters in the X, 2 meters in the Y, and you'll have 0 in the Z-axis. So I'm going to come down here and write out my unit vectors. I'm going to call it RAB, RAB, and RAC. Okay, and also given this was force AB is 100 newtons and force AC was 120 newtons. So that was also given on your diagram here. So RAB is going to be 4I minus 0J, or plus 0J, right? Minus 4K meters. And then RAC is going to be 4I plus 2J minus 4K. A lot of students have difficulties figuring out what direction you're going. So you can just find from point A to point B going positive X, not going anywhere in the Y, and then going down, so it's going to be negative, negative. Okay, so next thing I'm going to do is find my magnitude. Find my magnitude here, so it's just going to be 4 squared plus 4 squared. Take the square root, and over here it's going to be 4 squared plus 2 squared plus 4 squared. Take the square root. So here I got 5.66, or the square root of 32. And over here I got 6. 16 plus 16 plus 4. Yeah, okay. So next I would do my unit vector of AB, unit vector, this is AC, unit vector of AC. So this is going to be RAB over the magnitude of RAB, which is just going to be 4 over 5.66 minus 4 over 5.66, and this was I, and this was K. So EAB came out to be 0.707 I minus 0.7067 K. Over here you get 4 over 6 plus 2 over 6 plus 4 over 6. That's I, J, and K. So my unit vector is going to be 0.667 minus 0.33. That's I, J, and then K. There. So the next step then we're going to be is multiply the force times the unit vector. So that's going to be 100 newtons times 0.707 I minus 0.707 K, which FAB would then be 70.6 70.7 in the I, and that's going to be minus 70.7 in the K, and those are going to be in pounds. And then over here, I have 120 newtons times my unit vector. It's a minus. It's a plus, sorry. Which came out to be 80I. This is force AC, and this is force AB. Which came out to be 80I plus 40J minus 80K. So, my force resultant then, tired of yellow, my force resultant then is going to be FAB plus FAC. So now we're just going to add the components. So all we're doing is saying my force resultant is going to be 70.7 plus 80 plus 40J, because there's only just the J, there's no J here, minus 70.76 minus 80.04, and that was my K value. So my force resultant here then came out to be 150 I.7 plus 40J minus, you could say this, minus 150.8 in the K, and this would all be in newtons. Cool. So what is this? Well, this is our position vector using the force. So it's, again, if we were finding a resultant force somewhere in the x-axis, we're coming 150. In the y-axis, positive again, we're doing 40, and in the z-axis, we're doing a negative 150. So if I was to find the magnitude of this, you'd get 150.7 squared plus 40 squared plus negative 150.8 squared. Take the square root of all that, and you get your force resultant to be 217 newtons, and that's my magnitude. So both of us, or both of these chains holding up that steel plate there, is holding a total of 217 newtons. And again, it's 150.7 newtons in the x-axis, 40 in the y-axis, and 150.8 in the z-axis. I hope this helps a little. Hope this helps get your homework done. Please post questions for all of us online. Thanks.